Today's lesson is simplifying rational expressions. Rational expressions can be written as fractions, so you'll also see these called fraction or fractional expressions. So a rational expression is a quotient of two polynomials. Now remember, a quotient means to divide. So we're dividing two polynomials. We just worked with polynomials, and so now we're going to have polynomials being divided by other polynomials. So the way that we're going to find these values that can still make the equation true, we're going to do this just like we would with normal fractions. However, we are going to have some x values that make my fraction undefined. Remember, undefined means divided by 0, which we can't do. So when we end up with 0 in our denominator, we have a value called an excluded value. And you'll see me call these EV sometimes. They're also occasionally called restrictions. So you may hear that if you find videos or notes from other places. All right, so we are going to take a look at a couple of these where we are going to simplify. Now this is going to make us recall our exponent rules. So review your exponent rules before you start. Because if you have not gotten those mastered, this is going to be very difficult for you. All right, so what I do when I have something like this, 3x to the 7th over 2x to the 4th, I like to break these up. So 3 over 2 times x to the 7th over x to the 4th. That way I can simplify the number and simplify the variable at the same time. So 3 over 2 does not simplify, so we're going to leave it like that. Now this x to the 7th divided by x to the 4th, this is going to be our quotient rule, which tells us to subtract the exponents. So I'm going to keep this 3/2. This is now x to the 7 minus 4. So 3/2 x to the 3rd, or you might see this written 3x to the 3rd over 2. Either one is fine. All right, we've got B, 16x to the 11th divided by 8x squared. So once again, I'm going to go ahead and I'm going to take the numbers and the variables and I'm going to separate them. Now, if you don't want to do this, you don't have to. If you want to do it all in one step, that's fine. However, I do think it is the easiest way to go. So 16 over 8 simplifies to 2. And then once again, I am using the quotient rule on my variable. So I'm subtracting my exponents. So this is x to the 11 minus 2. So this is 2x to the 9th. Now for this one, my denominator can give me a value that equals 0. And actually on the last one too, I just forgot to do it. So for this one, what we want to do is we want to take the denominator and we want to figure out, okay, if it were to equal 0, what would the x value be? So I'm going to take 8x squared equals 0, and I'm going to solve for x. So I would divide by 8, so I get x squared equals 0. And then when I take the square root of both sides, I get x equals 0. So what this is this is now my excluded value. because in this problem, if x equals 0, then when I plug that in, my denominator becomes 0, and I can't divide by 0. So you can either write this as x cannot equal 0, or you can write excluded value x equals 0. You'll see it both ways. So if I did come back to problem A, it would be the same thing. We would set this up to x to the 4th equals 0, divide both sides by 2, take the 4th root, but anything with 0, it's going to stay 0. So my excluded value, so x cannot equal 0. All right, let's come over to C. Got 3x plus 4 divided by 3x squared plus x minus 4. So what I'm going to do is I am going to factor my denominator. So the top can't be factored, it's just a linear expression, but the bottom can be. So I'm going to, this is going to be bottoms up. So it's going to be a times c on the top plus b on the bottom. 3 times negative 4 gives me negative 12. My b value is 1. So I'm looking for numbers that multiply to make negative 12 and add to make 1. So that's going to be negative 3 and positive 4. And then my last step, I've got to divide by my a value and simplify if I can. This negative 3 over 3 becomes negative 1. So my factor becomes x minus 1. And then I've got this 4/3. So that would be x plus 4/3, which I would change to be 3x plus 4. And then I had that 3x plus 4 on the top. So now what I can do, I can go ahead and figure out what my excluded values are going to be, because neither of these factors can equal 0. So I need to figure out what values would make them equal 0, so those are my excluded values. So x equals 1, and then when I do this, x equals negative 4 over 3. Those are my excluded values. So x cannot equal, actually, I guess I'll do it a little differently. So excluded values, x cannot equal 1 or negative 4 over 3. So now if I'm looking back at my original problem, once I've factored it, I've got 3x plus 4 on the top. I've got x minus 1 times 3x plus 4 on the bottom. I can cancel out those 3x plus 4s. That's going to leave me with that understood 1 on the top. So this is 1 over x minus 1, and that would be my simplified rational expression. All right, D, we're going to have to factor both of these. So I'm going to start with the numerator. So a times c gives me 12. B is 7. So I'm looking for numbers that multiply to make 12, add to make 7. That's going to be 3 and 4. And then I'm going to divide them by my a value. That gives me 1/2 and 2/3. So I get, x plus 1/2, x plus 2/3. And then I'm going to rewrite those as 2x plus 1 and 3x plus 2. So that is my numerator. For my denominator, 6 times negative 6 is negative 36. B value is negative 5. So numbers that multiply to make negative 36, add to make negative 5 are 4 and negative 9. And then again, divide by my A and simplify. So this is negative 3 over 2. This is 2 over 3. So x plus 2 over 3 and x minus 3 over 2. When I rewrite those, I get 3x plus 2 and 2x minus 3. So I'm going to go ahead and do my excluded values. I would set each of these equal to 0 and solve for x. In this case, my first one, x cannot equal negative 2/3. And then for this second expression, x cannot equal positive 3/2. So those are my excluded values. And now let's do the final part where we actually do the dividing. So on the top, I've got 2x plus 1 and 3x plus 2. On the bottom, I have 3x plus 2 and 2x minus 3. I have 3x plus 2 on the top and bottom, so those cancel out and leave me with 2x plus 1 divided by 2x minus 3. Now, I know that the temptation is there to cancel out those two x's. You cannot. Do not cancel out the 2x. You can't do that because it is a whole expression on the top and a whole expression on the bottom. All right, let's go to E. We're going to factor these. I am not going to work through how to factor them. We should be familiar with factoring by now. We've done a whole lot of it. So I am just going to factor. This is going to give me x plus 1 and x minus 3. The bottom is going to give me x plus 1 and x plus 4. So first I want to do my excluded values. So I'm going to do x plus 1 equals 0 and x plus 4 equals 0 and solve for x. So my excluded values, x cannot equal negative 1 or negative 4. Then to simplify, there's an x plus 1 on the top and the bottom. So those cancel out. And that will leave me with x minus 3 on the top, x plus 4 on the bottom. Once again, you cannot cancel out the x's. This does not become negative 3 over 4. This is a complete expression on the top and a complete expression on the bottom. All right, for F, once again, I'm just going to factor these. So this is going to be x minus 2 and x plus 5. On the bottom, we're going to use grouping because there's 4 terms, just kind of as a reminder. So that's going to end up giving me x squared minus 4 times x plus 5. And then we would continue factoring x squared minus 4 to x plus 2 and x minus 2. And then we would still have that x plus 5. So for my excluded values, I'm going to set each of those equal to 0. And solve for x. So my excluded values, x cannot equal -2, +2, or -5. Now looking back at my original expression, I have x minus 2 times x plus 5 on the top, x plus 2 times x minus 2 times x plus 5 on the bottom. There's an x minus 2 on top and bottom, so I cancel those. There's an x plus 5 on top and bottom, so I cancel those. So that leaves me with 1 on the top and x plus 2 on the bottom. That would be my simplified expression. All right, sometimes when your factors are similar, but the signs are off, what you want to do is factor out a -1. It's going to help you out a lot. So we're going to look at this one right here. So 10 minus 2x over x minus 5. If I were to take out the greatest common factor on the top, the greatest common factor would be 2, and I would have 5 minus x. And then on the bottom, I have x minus 5. So we can see that those are very similar. I've got 5 and x on both the top and the bottom, and then I've got this negative sign in between. So what I'm going to do is I'm going to, instead of taking out a 2, I'm going to take out a -2. So 10 divided by -2 is -5. -2x divided by -2 is x. And then I'm just going to rewrite this as x minus 5. And now I have the same term on the top and the bottom. I can cancel those out. And it just leaves me with -2. Now, it's not always just going to leave me with a number, but it could. Oh, gosh, there it is. All right, so again, I'm going to go through, I'm going to factor these out. I've got, on the top, I've got a greatest common factor. Oh, but before I do that, actually, I'm going to come back because I do have an excluded value that I forgot to do. So excluded value, I'm going to set x minus 5 equal to 0, and I get x equals 5. So my excluded value is x cannot equal 5. Otherwise, the denominator would be 0, and we cannot divide by 0. All right, back here. So I'm going to take out a greatest common factor, which in this case is x. That becomes -x plus 3. And then on the bottom, when I factor this, I'm going to get 2x minus 1 and x minus 3. So again, you see we've got here, we've got -x plus 3. Here we've got +x minus 3. So what I want to do is I want to factor out a -x. And then my denominator stays the same. Now I've got the same value on the top and the bottom. Before I forget, I'm going to go ahead and do my excluded value. So I'm going to do 2x minus 1 equals 0, and I'm going to do x minus 3 equals 0. So I'm going to get x equals 1/2 and x equals 3. So x cannot equal 1/2 or 3. That's my excluded value. Now I'm going to focus on my polynomial. I have x minus 3 on the top and the bottom. So I'm going to cancel those out. And that is going to leave me with negative x on the top and 2x minus 1 on the bottom.